Good afternoon, Algebra 2. These are your notes for day 8. Today we'll be working on solving equations with rational exponents again. We have 3 steps basically to follow, and you can repeat this process over and over for every single problem in integrating PEMDAS and the rules for exponents and radicals that we learned last week and this week. So here's the 3 basic rules. You're going to isolate the term with the rational exponent. That means you want to get the letter, the variable, all by itself. Usually it's x. For number 2, raise both sides of the equations by the reciprocal. This is the key term right here. Everything has to get brought to the reciprocal on both sides. You'll see what that means as I explain these problems. And then finally, the last step is just to solve for the variable like you would in any other typical equation. So we begin with example 1. Example 1 begins with x to the 3/2 power equals 27. To get the variable x by itself, you have to raise the left side by the reciprocal, which is the exponent flipped upside down. Whatever you do to the left side, you have to do to the right side. So when I do that to the left side, 3/2 and 2/3 cancel out, and I'm left with just my variable by itself. However, over here, I now have 27 to the 2/3 or squared and third cube. I rewrote 27 to the 2/3 in radical form. Now what I'm going to do is I'm going to simplify it. 27 squared means I have 27 times 27 being multiplied underneath the radical to the 3rd power. I'm going to split it up into individual parts. I have 1 cube root of 27 times another cube root of 27. I need to know what number times itself again will give me a 27. If I look at my chart from last week, I know that I'm going to have a 3 here times another 3 here. 3 times 3 gives me 9. So my final answer will be x equals 9. That's the most basic example. Moving on, number 2. Here we have another one. The equation says 8 equals x to the 3/4. The first step is to raise everything to the reciprocal power. The reciprocal of 3/4 is 4/3. So I raise everything to the 4/3 power. The 3/4 and 4/3 cancels out on the right side, and I'm left with just x. On the other side, I have 8 to the 4/3, which can be rewritten as 8 to the 4th power times the cube root. That means there is basically an 8 times an 8 times an 8 times an 8, all underneath one radical to the 3rd power. I'm going to separate all these different 8s. And I'll say the cube root of 8 times the cube root of 8 times the cube root of 8 times the last cube root of 8. What number times itself again will give you an 8? That'll be 2 for all of these. So when I simplify all these, I get all 2's, and now all I have to do is multiply them. 2 times 2 is 4, times 2 is 8, times 2 is 16. Therefore, my answer is x equals 16 for number 2. Let's move on to example 3. Example 3 behaves the exact same way. So I'll begin by rewriting my equation, leaving enough room so that I can raise everything to the reciprocal on both sides. So I have 1/4 also raised to the -3/2. On the left side, the x cancels out, the exponents cancel out, and I'm left with just x. Now here's where it gets a little messy. A -3/2 means I'm going to have a fraction with 1/4 on the bottom raised to the 3rd power square rooted. That's what I really have. Now what I need to do with that is go ahead and separate it. 1/4 cubed means I have 1 over the square root of 1/4, square root, times 1 over the square root of 1/4 times 1 over the square root of 1/4. Square root of 1/4, what number times itself will give you 1/4? Will give you 1/2. So what I get is 1 over 1/2 times 1 over 1/2 times 1 over 1/2. I have a fraction over a fraction. When that happens, what you do is you bring the denominator to the top. So basically all these turn into just 2's. You have a fraction divided by another fraction. This goes up to the top. That's what's happening here. So 2 times 2 is 4. 4 times 2 is 8, so I get an answer of x equals 8. Moving on to number 4. Same exact thing again, but now I have a longer equation. So I'll go ahead and just rewrite it. I have x plus 2 already raised to the 3/4. I'm going to go ahead and raise it to the reciprocal, which would be 4/3, as well as the answer on the outside, which will also be raised to 4/3. These cancel out, and I'm left with just x plus 2 from inside of parentheses. So I'm going to have an extra math step to do. 8 to the 4th cube root. That's how I'm going to rewrite this, which basically simplifies to the cube root of 8, not once, not twice, not 3 times, but a total of 4 times. The cube root of 8 is 2, so I have 2 times 2, which is 4, times 2, which is 8, times 2 more is 16. So what I end up with is x plus 2 equals 16. I have to solve for x, so I'll subtract 2 from both sides, and I get x equals 14. That is number 4. Moving on to number 5. Number 5 is going to be multi-step. Before I can get this stuff, the 2x minus 6 that's in the parentheses, if I can get this by itself, I have to get rid of everything outside of it. So I'll get rid of this plus 4 by subtracting 4 from both sides. When I do that, the 2x minus 6 in parentheses, the 1/3 power falls down, and I get equals 7 minus 4 is 3. Now I'm going to go ahead and follow my rules, and I'll raise everything to the reciprocal. The reciprocal of 1/3 is just 3, or 3 over 1, power. When I do that, they cancel out over here, and I'm left with 2x minus 6 on the right side. 3 to the 3rd power is 3 times 3, which is 9, times 3 more is going to be 27. Now it's a two-step equation. I'll add 6 to both sides. That gives me 2x equals 33. Then I'll go ahead and divide everything by 2. And I get an answer of x equals 16.5, or 16.5. Yes, you can have decimal answers. It's not impossible. It's just not what we've been practicing a ton of. Number 6 is still more of the same. I have this equation. I can't get the x by itself until I get rid of all the stuff outside of it. So since I'm subtracting 12, I'll go ahead and add 12 to both sides, which makes sense because usually we don't want to deal with 0 answers. So I have 3x to the 2/5 equals 0 plus 12, which is 12. X is still not by itself. It's being multiplied by 3, so I'll divide both sides by 3. That gives me x to the 2/5 equals 4. This looks like example number 1. I'll take my x to the 2/5, raise it to the reciprocal power, 5/2, as well as the answer, which is the 4, to the other side, 5/2. These cancel out. I'm left with just x. 4 to the 5th power square root. 4 to the 5th power to the 2nd, or square root. That means the square root of 4, not 1 time, not 2 times, not 3 or 4, but a total of 5 times. The square root, I don't have to write the 2, but I'll just show you what I'm doing. The square root of 4 is 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Therefore, x equals 32. That's example number 6. Going on to number 7. For number 7, we have a whole lot of work here, but it is not as complicated as it may seem. First, I'm going to rewrite my entire equation, parentheses and all, with my exponent, and then raise everything to the reciprocal. The reciprocal of 1/5 is 5, or 5 over 1. I'll go ahead and just leave it as 5. I'll do my answer on the right-hand side to the same exact thing, to the 5th power. On this side, this all cancels out, and I'm left with just my original w squared plus 8w minus 3. On the right side, I'm going to have 2 times 5, which is 10. So I have w to the 10, with my denominator being 5 power. 10/5 simplifies to w squared. So I have a w squared over here on the right side. I'm going to combine like terms, and what I'm going to do is I'm going to go ahead and I'll subtract the w squared from both sides. When I do that, they cancel out. 8w falls down. The minus 3 falls down. W squared minus w squared equals 0. Now I'll solve for w. It's a two-step equation. I'm going to add 3 to both sides. and I get 8w equals positive 3. Divide everything by 8, and I get a final answer of w equals 3/8. A fraction answer in this case, and I want you to keep it in that form whenever possible. Going on to number 8, our final example. We have 3 times the cube root of 3m. So first thing I'm going to do is try to isolate my variable. I'm going to get rid of this multiplication of 3 that starts off the whole thing by dividing everything by 3. Cancels out over here. I'm left with the cube root of 3m equals 9 divided by 3, which is 3. The next step I want to do now is I'm going to go ahead and write this with a rational exponent. So I have 3m to the 1/3 power equals 3. I'm going to go ahead now and just like my instructions say, I'm going to raise this to the reciprocal. The reciprocal of 1/3 is to the 3rd power. Same thing over here. 1/3 to the 3rd power goes away, and I'm left with just 3m. 3 to the 3rd power is 27. I'll divide everything by 3, and I get the final answer of m equals 9. So there's your notes. Hopefully you understand what's going on. If you have any questions, feel free to ask your teacher. Best of luck on your assignment.